Hi, we're going to be reviewing the assignment that I gave you guys the other day. So, in this assignment, we were looking at geometric and arithmetic sequences using the same set of values. So, our values here were given 1 and 100. We're also given a number of missing values here, as you can see. Got 1 to start, 1 after 1, and 3 after 100. So my goal is I got to fill all of these in. Now, first question tells me if this is an arithmetic sequence, I gotta fill in the values. Now hopefully you remember, arithmetic sequences means we're going up by addition. So that means I have to get from to each step using addition. Now, the only two pieces of information I have are 1 and 100. To get from 1 to 100, I have to add 99. But you want to remember, that is not the only step you're taking here, because you're going from 1 to your missing value, and then from your missing value to 100. So since I have 2 steps embedded here, I gotta divide 99 by 2. Whoops. Fix that. 99 divided by 2. And I get 49 and a half. So that means each time I'm going up by 49.5. And you can do this as a fraction, you can do it as a decimal, doesn't matter. I'm opting for decimals this time. If I add 1 to 49 and a half, I'm going to get 50.5. If I add 49 and a half to 100, I get 149.5, or 149 and a half. Add 49 and a half to that, and I get 199. Add 49 and a half to that, and I get 100, excuse me. Oh, that's right. 248 and a half. So far I'm doing okay here. So for my next step here, I gotta do a little bit of work because I gotta go backwards. Now to go backwards, remember, when we're going backwards in mathematics, we gotta use inverse operations. So instead of adding 49 and a half going forward, I gotta subtract 49 and a half, or 49.5. So I'm gonna do that, and if my calculations are correct, I should get negative 48 and a half. You can check me if you want. I know it's right. Okay, so I filled in all my missing values. I am done here. Awesome. Is there a common difference or a common ratio? Now, common ratio would be happening if I was multiplying or dividing. In this case, I'm adding or subtracting, so I've got a common difference. And what is my common difference or ratio? As we've established, going ahead here, my common difference is 49.5, because I'm adding that to each previous value to get to the next one. Which leads me right into my next question here. Write a recursive formula for the sequence. Now I can write this as an expression, or I can write it as an equation. I'm going to go for the equation. And just so we can get some, a feel for different variables here, I'm going to use n. Again, remember with algebra you can use really any variable you want, but I'm going to go with n here. So to get to the value I want to get to, alright, I got to start with the value before, which means I'm going to use f of x minus 1, which tells me I'm using the previous output. Remember, this means previous output. Now, what am I doing to each previous output to get to the next one? As we've established, we use the common difference, which is plus 49.5. And I have myself a recursive formula for my sequence. Now for the explicit. This is where I saw some mistakes, so make sure you're paying attention. Now for the explicit formula, remember, you need an initial value. An initial value is when your input is 0. Now if I were to make a table out of all my values here, which I'm actually going to do right beneath it. Save some space, right? So I'm going to make this a table. And oops, it's alright. Erase the stuff on top here. Okay. So I'm going to make a nice input-output table. Now, as we always establish when we're doing these sequences, this would be my first value, second, third, fourth, fifth, sixth, 7th. So remember, the first value would not be my initial value. This is the mistake I saw in a lot of cases. That is not my initial value. My initial value is when my input is 0. So, of course, when we're thinking of the sequence, we're like, what do you mean the 0 number here? But that's how we find this initial value. So, if my input was 0, what would I have? So, as we've established, going ahead, we have to add 49.5. Going backwards, we have to subtract 49.5. So that's what I'm going to do right here. Minus 49.5. If I do that here, I'm going to get negative. Can I squeeze this in? Heck yeah, I can. Alright, negative 98. You can double check my math if you want, but I'm very confident that is negative 98. So I have my initial value. That's incredibly important. You can't do an explicit formula without that initial value. I'm going to make this an equation. So I'm going to use f of n, and oops, I used x up here. I'm going to just change that to n. So now, I don't have to go with the previous value notation. What's good to start out with here is it's good to start out with your initial value. Where am I starting? My initial value in this sequence is negative 98. What's my change? What's my common difference or ratio? In this case, I have a common difference of 49.5. I do that every time. Every time. So that means I'm going to be using multiplication here, so I can pop in my n. And now I have an arithmetic sequence here, and I have a recursive formula, and I have an explicit formula. So remember, always go back to that initial value. That was a big mistake I saw here, so make sure you're aware of that. Oh, graph the sequence as a function. I'm almost done. Alright, so you have a couple of options here. I'm going to go with 4 quadrants here. You don't necessarily have to, but I like to. That's because my initial value is going to be negative. Now, as I like to say, we really don't have to go crazy drawing these graphs. So I'm going to just make it pretty basic. I'm going to go up to 200. Break it up in the halves here, essentially. 150. 50. And then down here, I'm going to do the same thing. Keep them about the same distance. Now, we're just looking for a ballpark here. We're not looking for, anything that's going to win any art contests. You may be asked for more specific graphs at some point in time, but for right now, we just want to make sure we have the general idea of what the stuff is going to look like. Can I shrink this a little bit? Yeah, I hope so. Alright. So I'm going to start with my initial value, which is negative 98. So I'm going to go here at my origin. I'm going to go down to about 98. Put a dot here. And since it's not perfect, I'm going to label it. 0, negative 98. Okay. Now, when I input 1, I can just go up to my table here. I notice that, okay, it should be negative about 48.5. So it's going to be really close to 50 here. So again, I'm going to put a dot. And I'm going to label it. So I'll do it. Sorry, my labels aren't perfect. It's always good to have at least 3 points. So I'm going to go with 1 more. Now when my input is 2, I have an output of about 1. This will be really close to my origin here, so I'll put it like right there-ish. I'm going to label that 2, 1. And I have 3. That's good enough for what we're doing. So now I want a straight line. I think it'd be a perfect straight line, and that line represents my function. So I've got the graph. Got the graph, I got my explicit and recursive formula. I'm rocking it. Now, we're